Hi everyone, welcome to our knowledge sharing session. The purpose of the knowledge sharing sessions is to create a knowledge database so our community members get involved in Webiny easily, be it as a user or as a contributor. Without further ado, I will invite Adrian to continue his session today for API development with Webiny. Thank you.
Thanks, Albiona, for the introduction. Thanks everybody for joining today. Today's topic is API development with Webiny. So, as you may have already known, Webiny is a serverless product, I'd say. So we are working almost exclusively with the serverless technologies. And when it comes to development in a serverless cloud, things get a bit different than, let's call it, the traditional development. So in the traditional way, you have your own site deployed to your local machine, and you can test it out as if it was a normal regular website, right? But when doing cloud development, things get a bit different. You actually cannot have the cloud on your local machine. So imagine something like AWS or Google Cloud Functions or similar. It's not easy to have those services on your laptop and emulate them correctly. So basically, the only way to know that your application is working is to actually deploy it to the cloud. And in some cases, that is fine, but in some cases, it's not, especially if you are looking to have fast iterations with your code. So as you're typing your code, you want to test it out quickly. Deploying to the cloud won't cut it simply enough. But you can there are additional and different techniques you can apply there in order to achieve faster iterations, and that can be achieved mainly with writing tests. And we'll see how this works in the following sections. But for now, it's only important to realize that developing for the cloud is a bit different than the, let's call it, traditional development. Okay, so when it comes to Webiny, actually, before we move on into any kind of API development, I would just like to cover a couple of things related to Webiny, and so the technologies we use here and the overall architecture, so that you're basically more aware what's happening behind the scenes as you're developing. Webiny is based on a couple of core technologies. We like to use Node.js, and currently we are using MongoDB as our primary database. And of course, all of this is backed up with a GraphQL, with the GraphQL servers. And currently also we are working mainly with AWS, but hopefully in the future we'll also be able to work with other cloud providers like Google Cloud and Microsoft Azure. But as I said, currently we are exclusively involved with the AWS. So how does Webiny look like when you deploy it? Webiny actually consists of a couple of stacks. What I mean by stack, it's a set of cloud resources, right? So when you deploy your first Webiny project, you end up with a couple of stacks. One stack is exclusively responsible for everything API related. The other stacks are serving your single page applications. And so this picture, this image that we're looking right now represents the API stack. So as I mentioned, once again, this stack that is responsible for everything API related. And at first, it may seem a bit scary, but if we go step by step into it, we'll see it's not that complicated. So let's take a look. On the left side, we have a regular user, and he's making a simple API request, HTTP request. And the first resource that will capture that request is, of course, the CloudFront, AWS CloudFront. which will forward the request to the API gateway. And after that, it's everything is basically oriented towards Lambda functions, as we can see here. So we have this central Lambda function and a couple of all of these which represent separate services. Before I move on to this, let's cover a couple of terms here. So this Lambda here, Lambda function, is representing an Apollo gateway. And in order to better understand this whole picture, I'm going to just dedicate a few slides to the Apollo gateway and the whole Apollo federation technique we are using to achieve the Webiny API. So Apollo federation, we are using it. Webiny is based on the Apollo federation at the moment. And what that means is, as it says on their official website, the Apollo federation enables us to implement a single data graph across multiple services. So if we would take a look at this picture, we can see that Apollo federation architecture consists of a couple of key elements. The first element is right here. So in here we have different services, and they each define a distinct GraphQL schema. And what's cool about this, that these distinct GraphQL schemas are then pulled from this main gateway. And so this main gateway is composing these schemas into what we call a federated data graph. And basically what that means, when we have a web app or iOS app on this side, they can actually make queries and mutations over this gateway for every service that's connected to in the background. This basically enables you to have a very flexible data graph, because in the background you can actually expand these services and create new services in any way you like. And the only thing that the Apollo gateway cares about is that you specify all of the services that you actually want to be included in this main data graph. So now that we know this, let's go back to the initial image that we seen earlier. So we said we have two elements, Apollo gateway and separate Apollo services, right? So in this image, this Lambda function actually represents the Apollo gateway. So every time a request comes over the CloudFront, over the CloudFront and over the API gateway to this to the Apollo gateway, it will know actually where to, which services to call in order to fetch and in order to return the data that was initially requested by the user. So this Apollo gateway will communicate with all of these Lambda functions. And what these Lambda functions represent basically are the Apollo services from individual Webiny applications. What I mean by that, Webiny actually offers a couple of base applications that you can immediately use in your Webiny projects. And some of these applications are Page Builder service, Page Builder security. We also have internationalization service, we have Form Builder, and recently we also released our own headless CMS application. So all of these applications actually need an API, right, in order to work. And all of these applications and all of their services are represented by these lambdas. This structure enables us to have a very flexible data schema that's represented by this Apollo gateway. And basically, it enables you to easily add your own custom logic, custom services to this whole system. And what's also important, while doing that, you're not influencing in any way the other services. And it's also important that this service can be deployed on its own, and that makes you even more flexible in doing deployments. All right, so when I was talking about expanding the GraphQL schema, so basically if you were to create your own service, then this is where that service would go, right? And of course, the Apollo Gateway would be able to resolve it once a request comes from the user and requests something from your service. That service will be able to return the data, and the Apollo Gateway eventually will return the data to the actual user. This is just a high-level overview of our architecture, and for more information, you can always go to our official documentation pages. We have a couple of articles actually on the whole architecture that we are using. So I would encourage you to check that out when you get the chance. But right now, now that we are aware of these basic concepts, we're gonna just jump into the code and see how developing a simple API looks like. All right. So in front of us, we have a brand new project, a brand new Webiny project created. And I already deployed it. And I won't go into the details regarding the actual Webiny project setup and all the dependencies you have to install. For that, you can actually check the other videos we already have. Right now, as I said, this is a project that's completely set up from ground up, and I actually deployed it already. And if we go into the browser, I actually have local development already started. And as we can see, this is a brand new Webiny project. And by the way, when we are talking about creating new Webiny projects, we also offer some templates that can get you started easily. And what I mean by that, templates in a sense that you can actually select a new project. You can create a project that only contains our headless CMS app, or you can select a template which basically installs all of the apps that we offer that are in our repository. And this template that we have here is just that. It contains all of the apps that we currently have. So form builder, page builder, headless CMS, and so on. All right. Now that we have this covered, we can see this is our project. And let's cover the project just a bit so you can see what's going on here and how it's all organized before we move into the API development. So on the left side, we have some folders here, right? And the crucial folder for this video, of course, is the API folder, right? And in here, we can see we have already a couple of folders. Basically, if you take a look, you'll see that these are the folders of individual apps. So we have a form builder folder, internationalization, page builder, and so on. And what these folders represent is actually the API code that's being triggered in the actual cloud, right? So the goal here is to actually create our own folder. And in that folder, we, of course, code our own service that will be deployed by side with these already existing services. In terms of actual deployment, the core file that's important is this resources.js file. So if we scroll down a bit here, we will see that this file actually contains all of the cloud resources that are necessary for the Webiny API to work. So for example, here we have a security GraphQL. This is representing the GraphQL service for the security app. If we scroll down more, we'll see, for example, here we have internationalization GraphQL. The same thing, it's representing the GraphQL server for the internationalization app. So when I'm talking about these apps, these are those Lambda functions that we've seen in this graph, right? So I'm talking about these Lambda functions. And there are a lot of other things here as well. It's not everything about the Lambda functions. We also have, for example, in the end, we have the CDN and also the API gateway, which we have already also seen in this image. So this is the CDN, of course, and the API gateway. So it's representing the whole API, the whole cloud infrastructure that's necessary to be deployed in order for the API to work. All right. Now that we have these fundamental facts covered, we're going to try to create our own API. Before we do that, I actually wanted to show you one more thing. So this is the output which you get when you successfully deploy your API stack. And in here, you get some URLs you can check out. So for example, this is the main GraphQL API. So let's check what's that all about. So it's basically a CloudFront URL, which has a GraphQL appended on the end of it. And what we get immediately is the GraphQL Playground. And with it, we can actually check the complete GraphQL schema that was created from all of those services that we just mentioned. So we have CMS, we have file, security, page builder, and over here, we have also all of the mutations. So once we create our own API, our own service, we will eventually have another entry here, both in the queries section and in the mutations section. If we get that, that means we successfully deployed our own service. All right, and by the way, also this GraphQL endpoint is what you also will see in the network tab when you navigate through the admin app. So the whole admin app is actually relying on that GraphQL server in order to run properly. Okay, finally, let's see how we can create our first own API service. So in order to do that, you can do it manually, but we don't want users to do that manually. We want them to create it as easily as possible. So that's why we have this tool called Webiny Scaffold. And what's cool about it, it actually will offer you a couple of scaffolds that you can pick. And for our current case, we will need this GraphQL Apollo service scaffold. And if we pick that, the first thing it will ask us to enter the package location. So we basically want our API, our new API service, to be located in this API folder, because this folder, as I mentioned, represents the whole API stack that we are about to deploy. So let's create our own service. So I didn't mention what actually we will be creating. We will be creating a small service that will actually represent a small library. So a small library that will consist of two models. We will have a book model and an author model. And ideally, users will be able to access the GraphQL and over it, query the data and create new authors and new books and things like that. So for this particular service, I'm gonna type this package location. So I'm gonna call it my library. The next question it will ask us is to enter the name of the initial model. So what that means, every service, every Apollo service that we create basically consists of different models. And the core data model that we will need here, it can be book as mentioned by default, but we will make it the author. This is just as a help for us, so we can quickly check of what the API consists of and what we can do. We will see soon enough how that works in the actual API. So we created our own My Library service. This is not the only thing that was created here. If you remember, we said this resources.js represents the whole cloud infrastructure that needs to be deployed. And that's there. Here we can also find an update at the end of the file, we can see that this scaffold tool actually added another entry to the file. And basically, it represents the newly added API. So this is the first change. And the second change, of course, is this My Library folder. And if we open this, we'll see we have a couple of things already set up for us. And all of the source code for the API is, of course, found in the SRC folder. And in here, we have this basic index.ts file, which is basically importing different plugins in order to make the API work. And if you didn't know, Webiny is all about plugins. We actually try to use them as much as possible in every corner of the Webiny system. And this is not any different. So this is the folder that actually contains all of the plugins. And the two most important plugins are the GraphQL and models. So we're gonna just open these first and explain what these two do. All right, now we're looking at the models.ts file. And what this file represents is a list of all Komodo models that we want our GraphQL to have. So the Komodo model is something that is also part of Webiny. Basically, the majority of Webiny is created with this library. And what it basically does, and what Komodo is basically, it's a library of higher order functions that enable you to create data models. So I know this may sound a bit abstract, but in essence, the Komodo library enables you to create data models and rich entities which you can store into the database, which you can enhance with different functionalities and things like that. We actually have a separate video that will be talking about the Komodo library because the Komodo library is really, it's not a small library. It's a library that consists of a lot of packages and a lot of tricks will be shown in that video. So in this video, we're not going to focus on that one much because it's simply out of scope. And for now, the only thing that we need to know is that the Komodo is a library that gets shipped by default in every Webiny project. It enables you to create data models. And we will see in the following sections how we use it. So this is the models.ts, and just to conclude, this is the file that will contain all of the Komodo models. On the other side, we have this GraphQL file, and this is probably a bit easier to explain. It's also a plugin, which basically represents the schema we want our API to have, right? So we can see that the scaffold tool actually created the whole schema for us. So if we scroll down a bit, we can see we have basic get author queries and list author queries. And we also have the basic mutations all in place. So create author, update author, and delete author. So this makes it very convenient and easy for any developer to start immediately with his new service. There isn't anything special here. Of course, feel free to dive deeper into this, but the important thing is that you can really expand this in any way you like. And of course, you can create your own GraphQL types and operations, and we will cover that soon. So yeah, and the index file actually just exports everything from these two files. So this is pretty self-explanatory. Okay, I know I said a lot of information right now, so let's just see what happens if we tried to deploy Webiny again. So as I said, I deployed Webiny before, and without the new service we just created. Now we will try to deploy it, and we will see how our GraphQL schema will look like after we deploy it. So it's going to take a bit to deploy it. We're actually deploying the whole API. You have the option to deploy only a single service. But in this case, it's not possible because when we deploy a new service, the Apollo gateway needs to know that that service was deployed, right? So if we go back to this graph, I'm going to be going back to this graph probably much times. So as we can see here, this Lambda function is actually representing the Apollo gateway. Actually, I'm going to scroll to the top to this graph. This has all of the labels. So this is the Apollo gateway, right? And right now we are deploying a new Lambda function that represents our own API service. And if we were just to deploy that service, this Apollo gateway wouldn't know that service was deployed, and because of that reason, we need to actually deploy the whole stack again. So the important thing to note is that this is only necessary when you're deploying a completely new service. From this point on, we can actually deploy only our own custom API if we need it. So that will definitely spare us some time. Okay, let's check up the deployment. It seems that it's still going on. We're almost there. All right, everything's finished. If we check the logs, we will see that our API, my library, has been built and the Lambda function was created, and in the end we have a successful deployment, which is nice. Now, if we revisit our GraphQL Playground, and if we refresh that, we should see our newly added service in the schema. All right, it's here. So if we open this, we will see we have the base queries here, get outers, list outers, and we also have base mutations like create, author, update, and delete. So basically, if this is enough, you can actually move immediately to UI development. But this video will be only focused on the API. So let's go back to the code. And so as we've seen, we've deployed our API. It took us 126 seconds. Which, if you want to iterate fast, that probably won't be ideal for you. So that's one of the cons of the cloud development, as we mentioned in the beginning of the video, right? So you have to, so for every change, you basically have to deploy your code to the actual cloud in order to see if everything works as expected. The other thing that's pretty problematic with this approach is that you cannot debug efficiently. Actually, if you ask me, you cannot debug at all, because what you can do, as let's call it debugging, you can actually put some console logs in the code, and you can redeploy your code and then check the CloudWatch logs, which is pretty hard to find sometimes and pretty annoying. And yeah, basically what you can do, you can check the CloudWatch logs and check the console logs there. But as I said, I wouldn't call that debugging, and there must be a better approach of doing that. And so the problem is debugging and slow iterations. So we actually have our own way in doing that in API development. And we actually try to write tests. This tests folder is what contains the initial test that was created for us by the scaffold tool. And what tests enable us? Basically, with this test, we are actually creating our own GraphQL handler. So we are creating our own GraphQL service locally. And we are actually creating the same function that would be executed by the API gateway in a real cloud, right? And this enables us to basically invoke the function here locally. And of course, assert that certain things are in order. And this is much faster because now I can just run yarn test. And the test will be executed, and we know everything is in order. And basically, now I can continue adding more stuff to the API. And with these tests, I can not only assure that my API is working, but I can also quickly debug if something goes wrong. And let's see of also what this file holds. So this file just contains simple GraphQL queries with which we invoke the actual handler. So once again, we are invoking the handler as if it was invoked by the actual API gateway in the AWS cloud. All right. So now I wanted to show you how you can actually expand this API. And we will do this on the existing author model that was actually created for us. So if we take a look at this author model, once again, I'm not going to go too much into the Komodo. For that, you can check the other videos. But on this author model, we see that we have the title field automatically created for us. We don't need that actually, right? Because which author has a title, right? Let's make it more correct. Let's make this model consist of two fields, and let's call it first name and last name. All right. So we can very easily import packages from Webiny/Komodo. There you will find all the packages that you might need in order to create your model. So things like fields, hooks, or all other fields you might need, and so on. So this is the one and only model that we have that was created for us. And we just added the first name and the last name to the author model. So we made this change, but this also means we're going to need to make changes in our GraphQL, right? So let's search for the name. Just a second. Sorry, let's search for the title actually. Yeah, so the title is here. We're going to change this to first name, and we're gonna add also a last name. Right, and let's check if we have the title somewhere else. We should have it. So what I'm doing right now, I'm just changing every occurrence of the title field that we initially had to reflect the changes that we created on the author model. And you might have noticed that I'm making this change in a couple of places. That's because the title field is actually used on in several places, right? So, for example, if we take a look at the author GraphQL type, we had title here, so of course we had to change it to first name, last name. In addition to the author type, we also have the input type, which is used for mutations, for creating updates. And that means we need to change this here as well. So we're gonna just put it like this. And let's see, we have the title somewhere else. No, okay, that's great. And I also made changes in these types here. Let me see. So yeah, these two. We have where and sort types. These types are actually used when you go over to your Graphical Playground. These types are actually used when you're querying for authors. So in here, we have for example, the list authors, right? And if we take a look at the where argument, and if we go to the type details, we can see that since our API isn't redeployed yet, we have the old title string here in the authors list where type. So this is just a type that's used for the where argument. So just to be perfectly clear, if I go to authors and I make list authors, and in here I can type a where, and we have an autocomplete saying title, and then I can filter by title, right? And if we redeployed our changes, now we would have here first name and last name. So this author list where is this piece in the code that we just changed. So a lot of changes, but you'll get the hang of it. It's a bit easier when you have a scaffold that's already in place, and then you can just change and tweak the things you need. So you're not starting from scratch. And yeah, we changed the model, the Komodo model, and the GraphQL schema. So what we can do now is we can try redeploying our new service. And as I mentioned, we don't need to redeploy the whole thing. We can just do this. So we can write a name of the service we are trying to deploy. And we do this by just appending the service name. And if you're asking yourself, what is a service name? It's basically this. If you go to the resources.js, and if we scroll down to this entry that was added by the scaffold, the name I'm talking about is this. So this is actually the name of the resource. And our new service is basically a new serverless function with the name API My Library. So this is what I'm going to type in here. API My Library. And that's it. Oh, sorry. Sorry. Okay, so I basically missed this part. You also have to specify which folder you're deploying from. So I'm talking about this argument here. So this API actually represents this API folder. Yeah, so let's try to redeploy this thing again. So it's working. As we can see, it's building the API My Library. And soon enough, we'll have this. We should have this online. It's done. And as we can see, since we only deployed this service, it was done in 12 seconds, which is not that bad, I'd say. So if we open this GraphQL Playground again, and if we hit refresh, we should have our changes present. Hopefully, let's see. All right. Authors is here, that's great. And if we list authors, and let's see, where is it? So this is the author type. And yeah, as we can see, we have the first name and last name already here. And if I changed something here, we would see the autocomplete is now different, of course. It now tells us that we can filter authors by first name and last name. Okay, and finally, so I mentioned that you can iterate faster, right? That you don't need to redeploy this thing for two reasons. It's slow and it can't be debugged. And I'm going to quickly show you how that works. And so as we've seen, this is the tests folder that automatically gets created for you. This use GQL handler. Oh, I'm sorry, we're just gonna have to take a look at this initial test that was created for us. All right. So basically, a simple test is created for us. It basically tries to create three authors for us. And then in the end, it actually tries to use the list authors GraphQL query in order to fetch the list of all authors, and asserts that all authors are present in the GraphQL response. With this, we know that our service works. And I would just like to take a few seconds and explain that these tests are not 100% assurance that your service is working. Why? Simply because these tests are ran in your environment. These are not ran in the actual cloud. In the actual cloud, you have a lot of different restrictions and rules, and you have to make sure that your roles are all set up. You have to make sure that you can, access all of these services that you're accessing. And this thing here will definitely speed up the development, definitely will bring you faster results, and will definitely bring you some level of confidence that your service is working. But in reality, in order to be 100% sure, you need to have some kind of tests that are testing your system in the actual cloud. We like to do, for example, Cypress tests on systems that are deployed to the AWS. Cypress tests are awesome because you not only ensure that your UI is working as expected, you're actually testing that all of the API calls that are being triggered in the background are working as well. So yeah, I'd say that you need both in order to to be sure that your application is working 100% as expected. And last thing I wanted to show is, so since we have this test, we can try running a yarn test and see if it will pass. It won't pass, simply because we changed our GraphQL and our GraphQL schema and our Komodo model. Just a second. Excellent. So as we can see here, we have some errors. And this is basically, as I mentioned, it's because we've changed our GraphQL schema and our model. And let's try to fix this. So this is the assertion that's failing, right? And this is the part of code which is actually doing the list authors query. So let's take a look at this query and what it does. So basically, it's issuing a list authors query. And in here, we can see all of the fields that it's requiring, right? So instead of this title, of course, we need to have first name and last name. So this is why the error has been thrown here, because this query is trying to get the title field, but that field doesn't exist anymore. The same is here. This is the create author GraphQL mutation. And instead of saving our title, we are going to save first, and we're going to fetch these fields. Okay, let's check the test again. Let's check the test. So we will also need to make amends on these fields. So yeah, no more title. We need first name. So we're gonna say something like first name 1, just to be super simple, and last name 2. All right, I think we have everything in place now. Oh, of course, this last part is not correct still. So this is the assertion, and this part of the response is no longer as this, and we need to, of course, change it in the same manner we already did. So first name, we're going to expect the first name to be first name. Oops. So we're going to expect this. And with the first name, we're going to also expect last name to be returned. So this is going to be last name like this. let's check if this works. Okay. Let's see what's wrong. Oh, I know what's wrong. I actually didn't replace these numbers here. Sorry, my bad. This one is number 3. So we have 3, 2. Oh, this one is also, whoa. All right, let's try it again. Did we miss anything else? No, we didn't. And we can see all the test is passing, which means our service is working as expected. So what we see in here is that with this approach, the cool thing is that you automatically get tests for your API, right, for your service. And this makes it a bit easier to ship code with confidence. And the other thing, of course, is the debugging. And if you have an IDE that supports debugging in line, you can pretty easily attach a debugger. And as you may have already known, you can go line by line and inspect every line and see what's wrong, which again, in the cloud environment is not possible. So just a quick recap, what we learned today. We learned about the Webiny, and we've learned specifically how to develop your API with Webiny. We've seen how Webiny looks like, how its architecture looks like, and that we are using the Apollo Federation system in the AWS with Lambda functions. And we've also seen how we can utilize the Webiny scaffold tool in order to create our own API services very quickly. And we've seen how we can deploy to the cloud and actually perform and write tests so that our code works as best as possible, as correct as possible, I'd say. And with that, I would like to, again, thank you for looking at this video. I hope it helps you. And if not, feel free to always ping us on Slack or on our community forum. We're always there, ready to help. So thanks again, and see you in another video.